corner stuff. That'll be good. Wow, I'm really here. This is awesome. Good afternoon. How's it going? Y'all having fun? Look, I'm excited. I do a lot of these talks, but I've been to S4 probably 7, 8 years. This is my first time on S4 stage, so yay, I'm happy. All right, Monte Elkins, FoxGuard Solutions. We help patch all the OT stuff in your plant. Replicating nation-state style chipping attacks on Cisco firewalls. So who remembers this article about a year ago from Bloomberg? Anybody? Yeah? Okay. Yeah, maybe half, a third. The discussion was perhaps China had installed small chips in motherboards that were installed in large data centers like Apple and, Google and Microsoft that would allow remote access based upon this hardware chip that was added to the device somewhere along the way. So the implications of adding a chip to the device is that you can't detect that by patching the software, looking at the firmware, right? It's not there. This hardware does something else outside of that piece. It'll survive re-imaging. If you reconfigure it or put new firmware or software on the device, you didn't modify that extra hardware. And it's probably introduced somewhere in the supply chain along the way. The problem is that nobody owned up to actually showing the real device. Like when they contacted these data centers, they all said, no problem here, nothing to see, we're all good. So there was a question, right? It's kind of like aliens, right? You hear about it, but who has real proof? And we didn't find any real proof necessarily, so that's kind of a shame. So was it really true? Well, who cares, right? Let's make it true. So that's the point for today. Yeah, it maybe look better than that, okay? I mean, you try, but actually, I'll go reverse. Both of these things sort of happen at the same time: target selection and attack method. Dealing in ICS equipment, I'm thinking everything has a serial port. So, and serial port attacks are probably going to be fairly straightforward. We'll see how this works in a minute. And then it was down to a particular device. Well, almost anything in the ICS space has serial ports that you might send rogue commands to from implanted hardware. But Cisco firewalls also do their config by serial port, and they're a security device, and lots of people use them for protection, and so it probably crosses over to IT space. So I chose a Cisco device for my attack. Now these Cisco, who here has ever programmed Cisco router firewall stuff? Okay, again, maybe a third of you. All right, so typically you'll get it and you'll connect some cable like this to the serial port and do the initial config and then take it and put it out on the rack. All right, that's the way these usually get set up. Here's some of the tools that I used along the way. This 8-channel analyzer, it's like $8, straight from the Chinas. I think there's some irony, by the way, in using cheap Chinese tools to emulate cheap Chinese hacking. I don't know. But it allows me to look at multiple serial channels simultaneously, which is key to this upcoming attack, as we'll see. I need to be able to, from an independent device, I need to be able to see serial that's going in and serial that's coming out. That's 2 serial channels. Normally, we just see 1. It's also high input impedance, which will show up later on. There's free open source software for it. I don't get any money from any of this stuff, but if you are playing with serial ports, these are good tools to know about. PulseView is free software that works with that, and you can see here the actual pulses, right, coming back from the serial port, and then them interpreted as ASCII, bit by bit, start bit, stop bit, the whole thing. These serial communications usually run through a UART driver chip of some kind before that data goes out on the bus. There's a problem here, though, and that is that most of these devices, a lot of them, and in particular the Cisco device, uses plus and negative 15 volts as the signaling standard, or according to the standard. And that will pretty much fry the implant that I'm considering using, right? I'm thinking about finding a very small microcontroller and use it to send secret commands to configure the device through the serial port. Plus and minus 15 volts will fry this thing. It wants to see 5 volts maximum. But I discovered this application note. And what this application note says is that, that there are built-in protection diodes that can handle like small static charges and little bitty pulses. So maybe I can abuse those and connect this device directly to the serial connection and not blow it up. So theoretically, if I add a 15 kilo ohm resistor, these diodes are rated at 1 milliamp, I can connect this to 15 volt and negative 15 volt bus, hopefully without blowing this chip up. It turns out the 15 kilo ohm was a little high. In practice, I needed a lower resistance because I'm also trying to do signaling at 5 volts, 5 and 0. And the receive side of the serial port wants to see plus 15 and negative 15, right? So turns out I need a little more current, but 5.1 seemed to work all right, and nothing's really blowing up. One of the things I believe when building things is success lies on the far side of failure. And what I really want to do is fail fast. How quickly can I screw this up so that I can get on to how to make it work? So some of the first tests were I like to use Arduino boards. That's a Mega, but I grabbed it because it had some extra serial ports. Turns out I didn't really need it. But just to test the concept, right? Cheap board that I've got, I can connect it up, not do anything fancy, and see if I can do this 0 and 5 volt signaling and not blow the gates out of this thing with the 15 volts off of the actual serial line. And it works, right? So grab stuff off out of the drawers. I've got a bunch of these laying around. I use them for everything. They're, again, $5 from China. So now it's decision time. I can't put a board this big and hide it on a motherboard. I need to find a small microcontroller to use. Here are a couple of options that came to mind. The ATtiny 10, and that's what's in these forceps, whatever they are, in the tweezers right there. That's an ATtiny 10. And it looks like it had capabilities. And then there's this ATtiny 85. That's this bigger chip over here. The ATtiny 85 had some advantages. It had some built-in EEPROM, so I could do some more sophisticated kind of attacks. I ended up not using it, but I thought I might. And it's easier to program because I can use some existing software, and it comes on an existing board. So this is the board that it comes on. You get these off. It's called a DigiSpark. They come on Amazon. Here are 5 for $10. So, oh, by the way, I have a few of these. So if you want one of these afterwards, I'll tell you, to prove you're here, take a picture of me, tag me in on Twitter. I'm at Monte Elkins, and I'll give you one until I run out. But you can get these 5 for $10. So they're relatively cheap. The big chip on there is the voltage regulator. The small chip is the processor. But it becomes easier to program. I don't have to clip onto it or need anything special. I can just program it on this board, take it off, and then use the chip. So the next step is, before I even try that, let's wire up this entire DigiSpark board and see if it works. It's different. I mean, it should work, right? It always works, but test it before I go to a lot of trouble. And yes, looks like it's going to work. Anybody do any Arduino programming? A few, all right. So you can use a regular Arduino IDE to program this DigiSpark. Again, so I don't have to change tool chains and so forth. So So that made it quicker and easier. And here's a little link if you try to run the DigiSpark. It has a little quirk or two, but nothing bad. Here are the tools that I use. It's hard to sort of put a price on. People are asking, well, how much does this cost? Those boards are $2. You probably need some hardware, but if you're an electronic hobbyist, you have a soldering iron anyway. I have a hot air rework station that was $150. That's this thing that I used after I programmed it. I pulled this little chip off the board using the hot air. You don't really need that. And I put it back on with a soldering iron. Oh, I didn't list a soldering iron. It's hard to see small. You can get these little magnifying microscopes with display for $40. But you probably, if you do this work, you probably have soldering irons and so forth already. So the real tools aren't that involved. So at this point, my installation may look something like this. Here's this ATtiny 85. To simplify the attack, I'm doing this right now, blind injection. I'm not even looking at what comes back. I send the command, I wait a while, make sure it gets executed, send the next command. So I only need 3 wires. I need power, I need ground, and I need TX, transmit, out of this chip. So if I solder 3 wires on here, I should be able to stick this thing anywhere to this motherboard and run those 3 wires to those 3 signals and run my attack. There is a problem though. Those wires, like here's some pictures of other motherboards, right? Occasionally you do see these wires on a motherboard. They're called bodge wires, where they don't get things set up exactly right when the board is made. But they're ugly. And you don't see them very often, so they would be a pointer to it. And you really don't want to, I don't know whose board this is, but that's a mess, all right? So you really don't want to look like that. You want to look nice and neat and maybe slide under the radar. So I started to look for how can I install this with the shortest wires possible, or maybe I can get rid of a wire or two. And what I find is on the edge of the board, there's this can you can sort of see the edge of, but it's where the serial port goes in at the top, and then there are 2 USB connections. Well, those come up through the motherboard on these pins right here. These are 2 USB ports with power and ground and the 2 data lines. And here is the serial port on the RJ45. And here you can see the receive and a ground and some other pins. The rest of the pins are on these 4. But they're very close together, right on the edge of this board. Matter of fact, it works out there almost at the perfect size. Not quite, but almost. So this is a very small resistor. Who knows what its value is? Any guesses? 7 cents. Yes, I'm also saying value in another context. Do what? 0. Okay, well, we got to have a little fun. Yeah, it's probably even less than 7 cents. But this is a resistor that is 0 ohms. Basically, it does nothing. Why do you want to use a 0 ohm resistor? It's a conductor. It's a wire. And it sort of looks like it belongs there maybe more than these other bodge wires. So it turns out between that USB and the RJ45 port, I can shove that microcontroller. This is the resistor that I need for the TX to keep from burning this chip up with the 15 volts. And this is just the 0 ohm, because there's also ground over here, and that's where power has to come in here, ground is there, and it works out that I can put this straight on the motherboard with no wires at all. And it's a little crooked, and hand soldering is never quite as good maybe as machine soldering, but it's not bad for a quick inspection. So I can get it on there with no wires. I'm totally happy. Success. And failure. So in order to attack the Cisco device, I have to catch it right when it boots up and send it these escape keys there's a password bypass procedure for Cisco. If you ever forget your password, you connect to the serial port and you press the escape keys and you go through these things. But at this point, my attack chip was not getting power until long after that timeout, sort of like BIOS at the beginning of a PC, right? That it timed out and the system had booted, and 5 minutes later, I'm getting power. The Cisco device was not turning on power to the USB port until after it had booted. And I need power from the beginning. But it fits. I wanted to go there, but I don't have power. So I'm starting to look around. Where's the closest place I can get power from? Maybe I'll just run one wire. It won't be that bad. And I find not far away this chip, this dual channel power distribution switch. And this is a chip that the CPU is using to turn on and off the USB port. It basically gets power in here, and when it gets the enable from the CPU after it already boots, it sends power out a couple of different outs. In here, out A and out B, because there are two ports. I'm like, I can run a wire over there and get power. Or, and this is probably the part I'm most proud of. Or, instead of doing that, this pin where the power comes in and this pin where the power goes out are really side by side. And if you've ever done any soldering before, you know sometimes you make a mistake. It's called a solder bridge. You accidentally drop some solder and it crosses between two pins because they're really close together. Well, in this case, I put a solder bridge between those two pins. So this mistake is part of the hack. A solder bridge is part of the hack. So anyway, kind of proud of that. So that means I get power the whole time as soon as the power comes up. Look, that chip also is kind of a fuse, and like if you use too much power, it'll shut it down. Well, that doesn't work, but who cares? It's not going to be my firewall. All right, so now I'm in. Now I've got power. And here is the pictures. You've seen me install it. Can you find my new installed chip? That's the top of the motherboard. That's the bottom of the motherboard. Can you see it on the motherboard? Do what? Bottom right-hand corner. Yeah. You might come around later. Yeah, bottom right-hand corner. Right, hold on. Right there. So I did publish this on Twitter, kind of low res. And where is Andrew Zonenberg? Is he in here? All right, he's a buddy of mine. He's around. He's like, oh, I see it. Nobody would ever put a chip down there because of the fill and the RF and the back. I'm like, whatever, Andrew. Yes, you know, you do this all the time. He spotted it right off. And I had another couple of people. It's not impossible to see, but if you're not doing this a lot of the time, it might be sort of difficult. But to even get there, you have to take this firewall apart. 14 screws, take the motherboard out, turn it over, look on the bottom. Probably not what most people do when they get a new piece of expensive equipment, is take it apart, take all the screws out, and turn it upside down. But it's not impossible to see if you're looking for it, right? And it could probably spend a few minutes and teach anybody to find a bad solder joint. There are some other places we could hide this payload, though. For instance, this is that port, the two USB ports and the RJ45 serial port. It's surrounded by this metal shielding can. If I turn this motherboard upside down, desolder the 4 pins that hold this can in place, pull the can off, and look into the back side of this plug, that's this. And there's almost the same amount of empty space in the back hole of this plug as there is in the front. Plenty of room to put a chip, put the can back on it, solder it back in. Now you're going to have to unsolder all the cans on this motherboard to look to see if there's anything inside of those. So now you get a brand new piece of equipment, and you're going to desolder these pieces, maybe not, and pull it apart. But one of the reasons why I put it just left it on the bottom is because, look, if I'm going to talk about it, it's much more fun to actually be able to see it than say, oh, it's hidden in this can, believe me. Oh, and there's this. You can get these on eBay. Warranty void if removed. It has a hologram, barcode, and individual serial numbers, right? So I put that across the seal. Nobody's going to open that up, right? Warranty void. It's like It's like supply chain jujitsu, right? You're using their tools against them, right? And that's supposed to protect your devices. Nobody's been in here, so don't open it up. That's my secret weapon. eBay is awesome. All right, so this is our typical config cable for a Cisco router. I'd like to say I was brilliant, but this was really an accident. It turns out that the resistors that I need to protect the microcontroller means that signal is very weak. It's efficient, but it's weak. If you plug a regular serial cable into the device, it overwrites my chipping attack. So now imagine this. You bring this device down, you set it up, you plug the serial port in it, you don't see anything, you do normal programming, you reboot it, you test it, everything is beautiful. You disconnect it, and you put it in the rack and reboot it, and now something goes wrong because your serial port is not overriding the commands. So, in order to actually see those commands go through, that's one of the times I come back to this 8-channel analyzer. It's high impedance. I can connect it so that I can see the commands going out to the router, the firewall, and the commands coming back so I can watch it happen without overriding them. And when we do that, this is what we see. So here the firewall starts to boot, and it tells you straight up, press break or escape to interrupt the boot. And that's where I have to hit those out pretty fast. And so I interrupt the boot. I go to ROMmod. If you set this config register to OX41, you can now boot the device, and the password is not required. This is your password reset feature documented by Cisco. I've had the discussions with them. I got a call. It's okay. Now I can change to enable mode, which is root, admin, access in the Cisco world, without a password. At that point, and this is all being done by the chip that's implanted. We're just watching this as it goes along. Then enable grants me admin access, root access to the device. I can copy the startup that the person who's trying to set up this firewall into place. I don't know what all their routes are supposed to be if I'm attacking it from a chip remotely. They've already set this up, right? So what the chip will do when it gets rebooted without their serial cable is it's going to copy all of their routes into place. Then it's going to generate an RSA key. Why am I going to generate an RSA key? Yeah, because if I'm going to own this device, we should do it securely, right? And then we have an account, we turn on remote access to the SSH port. And so this terminal window down here is connected by Ethernet port to this router, a firewall. And if I do an in-nap scan after this reboot, we see, look, SSH is enabled. Oh, right? Now the SSH, maybe they had it turned on, but even if they didn't, it's turned on now. And at this point, I run an SSH to the account I added, give it the password that I added, and enable, so back and have root. Oh, by the way, the last thing it does, the chip does on the firewall, is it executes this ping command. So it lets me know it's been hacked and been rebooted. So there we go, winning. Oh, thank you. So, this is all just based upon the Cisco password recovery. Document the steps that we just talked through. So, their chipping implication is you cannot detect this by looking directly at the config, particularly if you have the serial port connected, because the attack doesn't happen while your serial port is connected. You can put new firmware on, you can put new configs on, and as soon as you unplug the serial port and reboot it, now you're owned again. And you have to think about the debug cycle too. Now, it did maybe turn on a SSH port, it did add an account, so if you set this up and you put it in the rack, maybe eventually, a few months later, you go back and test it again. You're like, wait, something's different. What's wrong? And you'd maybe change the config and reboot it and be like, it's back. And you change the config, reboot it. So you take it out of the rack and you bring it to your desk and you hook up the serial port to it and you set it, oh, look, it's fine again. You put it back in the rack, right? Turn it back on, reboot it. It gets owned, but you don't look at it again for 3 months because you just fixed it. So I think that's fun. There are some things we could do to enhance it, but that's for the future. Anybody actually remember this movie? Now, at least a few of you. If you haven't seen it, right? If you weren't born yet, go see this movie. I used to call these attacks the Miyagi attacks because I thought, right? The line about this kick, right? If do right, no can defense. Right? And so that these attacks were, if do right, no can defense, right? There's nothing you can do to reset it or stop it or whatever. I don't really believe that now. I think most of these have some ways to defend against them, define them. One is you could carefully look at the motherboard. Right? It's not too hard to see, right? You saw it, and some other people have seen it, and you can learn to see it. And if you go check your configuration of your device on a regular basis, see if it's changed, scan it on a regular basis, see if an SSH port is open that you didn't have open, maybe do some radio frequency baselining. Like later on, I might try to exfiltrate this with radio, whatever. There's also, by the way, Cisco has this line. They asked to make sure I included it, but I was going to include it anyway. Whoops, they have this line, no service password recovery. If you set that, you can't bypass the password on a device. Has anybody ever seen that line set in a Cisco router? No. Matter of fact, and these that I bought off eBay, they weren't set either. The full configs were on there. I even own some of the passwords, but that's somebody else's password, so you don't get those. So nobody ever uses it. Now, even if you did, if one of the enhancements was that I also looked at instead of just the TX line out of the chip, the RX line, when you first set up the password, I could store it as long as it was set up across a serial port, and then I would own the password as well. So, I mean, it's something you could do. It's not 100%, but I'd say it's recommended. Nobody will do it because you're afraid, right? You forget your password, and then what are you going to do with your device? Well, that's a little exaggeration, but still people won't do it. What I learned is that doing this attack is not very difficult. And sort of the installation on the motherboard isn't difficult either. What would be hard would be getting it back into the supply chain. You know, for me as an individual, I could probably eBay them, which is where I got these from, right? Get newer models, nicer models, cut the price a little bit, shove them up on eBay or sell them. Might be able to social engineer a company. Hey, you need to buy a bunch of firewalls? I got a good deal for you. I might be able to get in there by being a component supplier. What if I just sold that can with the USB and RJ45 ports and sold it to a manufacturer? Right, I could pre-doctor those, perhaps. Otherwise, I probably need, right, interdiction power, right? All useful intelligence agencies can delay a package en route, add a little something, something, right? All countries do that, including ours. So I think it's currently really for only very targeted attacks. Why? And it's on the horizon. That it's probably not for right now. And why not now? The reason this isn't really an attack unless you're a special snowflake is that between the time I first started doing this and first talked about this attack, Cisco had something like 3 remote code execution vulnerabilities in their iOS. They're shipping it with vulnerabilities, right? As long as they do that, this is a lot more work, right? So it's not for now, it's for after we get software more under control, we get patching more under control, we get configurations more under control. Then you will push the attackers into the hardware. But we have a lot of work to get there. So I'm trying to say it's not that hard, and it's something you should be aware of, particularly if you're doing all the right things. But it might not be something you worry about right now, or you're not doing things. So, last item is, remember I was saying, well, we look for bad solder joints, we look on the motherboard. When I got this thing from eBay, I see factory original schmoo. There's some kind of glue, silicone, something here, and there's some kind of something on the board. Why do I say that this is factory original schmoo and not somebody has already compromised the hardware? Because who would do something like that? All right, thank you very much. I'm Monte. If you take a picture, tag me on at Monte Elkins on Twitter, and I've got a few of these chips. So.